Uh, Hello, everyone. I'm Laura Voinea from the University of Glasgow. So today I'm going to talk to you a bit about Mailboxer, which is a prototype tool that we've developed at the University of Glasgow as part of the Stardust project. And Mailboxer is a tool that uses mailbox types to statically detect communication errors and Erlang. This is joint work with Duncan, Simon, Daniel, and Phil. And Duncan has been the main developer of Mailboxer. Okay, so actor languages, and in particular Erlang, has been very good at building scalable and reliable distributed systems. However, as any other language, it's still prone to communication errors. And here we're going to use a simple example of an ID server to highlight some communication error classes. So this is a very simple example given an Erlang-like pseudocode. And on the left-hand side, we have an ID server which receives an init, and the number goes into a forever loop where it receives GET requests from a client and then sends an ID with a unique number. And on the right-hand side, we have the client that spawns the server, sends an init message with a number 5, sends a GET and its PID, and then receives an ID tag and the number and prints it to string. Okay, so what can go wrong with this very simple example? Well, we can have a payload mismatch. So say we have on the right-hand side, we send a string 5 rather than a number 5. Well, that's the wrong type, and that's going to lead to a crash. What else can happen? An unsupported request. So again, say on the client side, we mess up, and instead of typing get, we type GT. Well, that's wrong type. And that's going to lead to mailbox jump, not necessarily a crash, but a silent error there. What else can go wrong? Well, an unexpected request. So say once we've sent the initial init message, we send a second init message. That's going to cause a crash on the ID server side, which only expects one init message. We can also have an omitted reply. So say the client simply doesn't send the ID. The server simply doesn't send the ID. What happens then is that the client gets blocked, it keeps waiting on ID forever, and that leads to a crash on the program. Well, communication errors aren't exactly cheap. They lead to defensive codebases, defensive code with bloated code bases, extra maintenance for the extra code, can lead to late discovery of these communication errors with processes crashing at runtime, blocked processes, or mailbox junk. And our goal here is to fail fast and fail early, detect as many of these errors at compile time in the development process rather than waiting for it to crash in production. So here come mailbox types. These are a novel behavioral type discipline, first introduced by Ugo Del Guro and Luca Padovani in 2018. And they are very much targeted to actors. And to representing the pattern where you have multiple senders with one receiver being the mailbox. We have mailboxes that describe this interaction. And in here, there are first-class entities that are typed themselves rather than typing the processes as you would have with different behavioral types. And the process interaction is then implicitly captured via the mailbox state at any given time. Later on in 2023, Fowler et al. Introduced PAT, which is core programming language with first-class mailbox types. And the type checker from PAT is what we use in Mailboxer as the backend. So mailbox types are represented by a capability and a pattern, where the capability is either bang P, where P is the pattern that's represents messages that must be sent, or question mark P that represents messages that a mailbox can contain and then must be consumed. And the patterns are commutative regular expressions that describe the configuration of messages in the mailbox. They capture out of order message deposits. They capture selective message reception. And for example, if we think about the ID server that we saw previously, receiving one init and many get messages is represented by this question mark init dot get star, where star means zero or many get messages. Send one ID message is represented by bang ID, and receiving many get messages and one init messages is represented in the same way as previously, with question mark init dot get star, because it's a commutative operator. So mailbox types promise us tool that can work at compile time, so we can get early error detection, eliminate some of the defensive code around communication. It promises us a tool that can execute fast and is usable during development. We can annotate the code with type annotations to represent the mailbox types, which also lead to documenting the developer intent in that code. Something that is compatible with existing tools and available, and something that scales. However, it's not that straightforward to apply mailbox types to Erlang, because in mailbox types and in PAT, mailboxes are first class, while in Erlang they are monolithic. So what does it mean that they're first class? Well, processes can create and free mailboxes at any time. They can own many mailboxes, and they use the mailbox ID for receiving. While in Erlang, we don't really have that. The mailbox is tied to the process lifecycle. One process owns one mailbox, and they're implicit when receiving. They kind of act as a bag where you have messages that are coming from different protocols all in the same mailbox, which means that if you try to track them, that's very quickly becomes very difficult, and you also get type pollution with different protocols maybe having access to type information that they shouldn't. So For that, we use interfaces to isolate the mailbox type and the state. So an interface we can think of as a set of messages that the mailbox can receive for that protocol. It gives a partial view of the mailbox, again, for specific to the protocol, and we use it to annotate the function, the specific process functions. This means that we get to isolate message types and type check them against interfaces. This approach minimizes type pollution. And we can also reason on the states by considering the smaller message set. So here I'm gonna go to a demo. So if you wanna follow along, scan the QR codes and we can have a look together at the example and try to fix some of the errors that we encountered earlier. So this is Mailboxer Sandbox, kindly built by Phil's master's student, Zubair Khalid. So I'm just gonna switch to that. Is the sharing still working? Okay. Okay, so let's revisit the ID server example and have a look at the mailbox types that we use for it. So we start off with defining some types for init, for get, and for ID here. So init is a tag that will also carry an integer. Get is the get tag, and we have the ID client mailbox here, and ID is an ID tag with an integer. Later we see the messages that the ID server mailbox can receive. So get PID, init, and get. And the client mailbox can receive, which is a PID and an ID. We also associate these interfaces with the functions that will use them, either using the new modality for when we use a new mailbox or the use modality. So that's going to be the continuation of ID server mailbox. We also need to annotate the receive parts with what we expect the mailbox content to be at the time that we are going to receive using it. So for each of the receive, we annotate the mailbox with what we expect it to contain in each of them. And we can also run this example. Okay, type checks. So let's go to can you fix these? So this example contains all of the errors that we had before. And if we run Mailboxer, it's going to give us an error. So it's going to say message tag GT not supported by interface ID server NB. And indeed, if we go to that, well, that's not really supported. It's looking for it to get. So how do we fix that? We go to message tag, fix it, get, let's run Mailboxer again. And we have a new error. This time it's a type mismatch error, expected int but got string. So I believe that this is for sending a string 5 rather than number 5. So let's fix this one as well. Okay, so that error has disappeared, but now we get a different error. Inferred message pattern is different than the one that we've asserted. So rather than being one init message, we have two init messages. So right here, you can see that we're sending a second init message, so we can get rid of that. Run Mailboxer again. And we still get an error. So inferred expecting, okay, produce the message pattern ID. So this is because we are not sending ID. No. And now if we run Mailboxer again, hooray, it's successful. Now I know this is a fairly simple example, but if you want to have another look at it, there are a few more working examples here. So these come from the Voinea benchmark. And if you want to have a play with the tool itself, have a look at the code, you can go to the about, go to the original Mailboxer, and you can have a look at the implementation and all of the examples contained therein. Okay, let's go back to slides. Okay, so to sum up, Mailboxer is a static tool that implements mailbox typing for Erlang codebases. It embeds the communication model in the code using annotations that represent the mailbox type interfaces. This also documents the programmer's intent when writing the code. And what they thought the communication pattern should be between the different processes. Now, something that I've not shown in this demo, but you can have a look at if you want to, and the repository is that it scales to specify multiple protocols. And it's also compatible with other tools such as dialyzer, equalizer, etc. Okay. As for development plan, we're working on supporting more of the Erlang syntax, such as lists and array tuples. For longer term or medium term plan, we plan on adding type and pattern inference to have less verbose mailbox types, especially in the case of multiple protocols. Also planning on adding gradual typing to it to allow it to work with partially annotated code bases. Obviously, a big goal is to have it working for OTP. Okay. I think that's me. Thank you.
Yeah. Since this basically like documents protocols, like you said, have you thought about using this to generate fuzzing or like mocks for client and servers?
I mean, that would be a very interesting thing to do.
Yeah, I thought it would be like really cool and powerful to do.
Yeah.
So what will be the main challenge when you want to scale your type checker to the full scale of Erlang language? That is the one question. And the second question is that actually I'm a big fan of Haskell compiler, but sometimes Haskell compiler GHC produce type error message that misread the location of real type error. So in your experience, do you have any have you any attempt to do research on producing more kind error messaging related to the communication, something like that? So that is the second question.
So for the first question, that is a lot. So those are That is a very big task. So some things that I've already listed under the development plans would be milestones to get there. So again, we're still only supporting a subset of Erlang, so we're working on adding more of that, and we're also going to work on trying to support ODB, but that's still a bit away. As for good error messages, that's a good question that I've not thought about very much. So Duncan is the one that has implemented that, and I'm sure that he would be able to talk more about it. Yeah, I don't know.
Thank you.
Thank you.
There's no need to bring mailboxes as in path into Erlang, right? So with this interface that you described, we don't need to bring mailboxes as a value because it's self-contained in the self process.
So what's happening is that at the moment we're using the same type checker as for that for Mailboxer. Now that could be re-implemented in Erlang if we wanted to, or a different one could be swapped. At the moment, that's very useful because if we do an extension and path, it's something that we can reflect in Erlang and vice versa. So that's sort of how. Yeah.
Sorry, you spoke about gradual typing, and you said that because you want to type code that is partially typed or not. I was wondering about gradual typing, but for Mailbox type. Sorry, in the sense that can you just say, okay, I want to specify not all the Mailbox, but just a few ones, and have something like dynamic for the content of. So is it possible to introduce this Mailbox typing gradually also?
So that's in the future plan.
Okay.
So yeah, that's something that we want to do. Realize that not everyone's going to put in the effort to add Mailbox types to their entire code base. Or they might not want to add Mailbox types in their code base, but again, that's not something that we currently support. It's something that would be quite nice to do.
And what would be the difference with respect to gradually typing the programs? I mean, or just too early to answer?
Sorry, I didn't catch the last thing.
Or is it too early to have a number now?
No, I think it's a bit early to have an answer now. Yeah. To be fair with Mailboxer, we do very much focus on the mailbox typing aspects, and we leave the rest of it to other tools. We kind of see it as something that can be used with the rest of the Erlang tool. Well, thank you very much.